Welcome to our tutorial on how to do stoichiometry with molarity, so concentrations of substances in a chemical reaction. So here we have this chemical reaction here. So let's go ahead and read the question. So how many milliliters of 0.75 molar HCl are needed to react completely with 225 milliliters of 1.3 molar CaOH2, calcium hydroxide? So if we look here, again, we need to figure out where we're going to start. Now, if we look at our stoichiometry map, we can see that since we have the molarity of both of these substances, okay, we're given the concentration, or if you were trying to solve for molarity, you know that you're going to be using one of these pathways here. Okay, now for this one, okay, if we look at it here, we're given 1.3 molar of 225 milliliters of CaOH2. Now, as we're looking at this here, we're given both the molarity and the volume. So we know that this is where we're going to start. We couldn't have possibly started here because we're only given the molarity. We're only given the molarity, and we're trying to solve for how many milliliters or what the volume is. Okay? Now, remember, we always need to convert to liters when we are doing a molarity conversion. So if we think back really quickly, if we're given 225 milliliters here, okay, that's going to be, if we write out our conversion factor, so 225 milliliters, okay, our conversion factor from milliliters to liters is 1,000 milliliters to 1 liter. So if we go and plug that in, so dial that into our calculator, so 225 times 1 divided by 1,000, okay, that's going to give us 0.225 liters. Okay, so now we know that this is where we're going to start and this is where we're going to end. So let's map it out on here. So if we look here, if we're going from molarity to moles, okay, that's going to be our first step. And then, so remember, we're always converting to moles first. Then we have our mole bridge. So then from our mole bridge, we need to convert to molarity down here. So we need to look very carefully at what the equations are that we're going to be using to make each of those steps. Now, if we look here on this side, our first step is going to be molarity times the volume. So remember how we wrote this in here now, so we're not able to just plug it straight in sequence like we did in some of our other questions that we've gone over. So here, we're given 1.3 molar of CaOH2 and then 0.225 liters of CaOH2. So that's where we're going to start, because we need to convert to moles first. So the way we do that, molarity times volume. Okay, so we've got 1.3 molar of CaOH2, and then we've got 225 milliliters. So again, that was 0.225 liters. Okay, so if we go through and plug that in, that's going to give us moles. So again, we're going from here to here. So we're ending at moles there. So we have 1.3 times 0.225. So that gives us, we can round that to 0.29. So 0.29, and now that is moles of our starting substance, CaOH2. Okay, so now we're at this step right here. So now, as always, we need to go through our mole bridge. So this step, we still plug in sequence. So we've got moles of CaOH2 up here. So we need moles of CaOH2 down here. Okay, so we're trying to get to HCl, which I should probably underline that there. So we're trying to get to HCl here. So we need to look up at our balanced equation. Okay, so we've got moles of HCl. And if we look, we've got 2 moles of HCl, 1 mole of CaOH2. So 2 moles to 1 mole. Okay, now this is where the tricky part happens that a lot of people struggled with. Now we're right here. So this is where you need to stop, and then we need to plug into one of these equations here because we're trying to get to molarity. Okay? Well, I should say the molarity island, even though we're trying to solve for the volume here. Okay? So we're given that molarity of HCl. So if we look really closely at this equation here, if we're trying to solve for volume, we're just going to take the amount in moles and divide it by the molarity. So our volume is going to be solved by taking the answer from this part here. So 0.29 moles times 2 divided by 1, and then we plug that into our equation. So if we look there, so we've got 0.29 times 2, and then we would technically divide it by 1, but we don't have to do that, so 0.58. That's going to be 0.58 moles of HCl. Okay, so now remember, this is where we need to stop because we can't just plug it in sequence. So now we're going to take this amount in moles and divide it by the molarity. So you've taken your answer here and you're plugging it into this equation. So remember, like we said, so volume is going to equal moles over molarity. So we're going to take our amount in moles, so 0.58 moles of HCl, and we're going to divide that by the molarity, which was 0.75 molar. That's what the big M means. That means molar. And again, we do need to be careful to not make this a little m, because little m is actually something else in chemistry that we'll talk more about second semester. But we also don't want to confuse it with moles because it is very different here. Okay, so now we go ahead and just plug that in. So that's going to be 0.58 divided by 0.75. Ooh, you can't really see that. So 0.58 divided by 0.75. So that's going to give us 0.77 liters. And that's of HCl. Now we're almost there. We're not quite done because we need to convert that into milliliters, because that was what our question was asking. It wasn't asking for liters. So same thing, we just need to plug in our conversion factor. Okay, so if we've got liters up top, we need liters down below. So 1 liter equals 1,000 milliliters. That's our conversion factor. So we just go ahead, plug that into our calculator again. So 0.77 times 1,000. So that's going to give us 770. So our final answer here is going to be 770 milliliters of HCl. So that covers all of our combinations of stoichiometry, and I hope that that helps clarify some misconceptions that we might have been having. So good luck, and if you have any further questions, please don't hesitate to contact me.